Hello, my name is Alexander Kozlov. I'm a CTO at CloudBEAR, and today I'm going to talk about customization example, which we did on demand of our customers to accelerate performance of national crypto algorithms in Russia. We at CloudBEAR have a wide portfolio of RISC-V IP cores featuring rich set of standard extensions. As well, we support crypto extensions in some of our cores. Our customers use crypto acceleration support for different kind of applications. For example, they use our BM610 core as a 64-bit microcontroller core for large SoCs, working as a housekeeper core, and also maintaining the security boot process. They also use our Linux-capable out-of-order core to run software on embedded systems like VPN software and IoT gateway software, which need fast and secure connection to the cloud. For worldwide customers, their demand is fulfilled by use of K extension. However, we have domestic Russian customers which wants to support national standards as well. National standards known as GOST. Specifically, the standards are listed on this slide. We have two block ciphers in there, Kuznechik and Magma, and hash functions Tribok, which not only hash, but also used as an initial part of digital signature algorithm. Based on applications demand, we started with 64-bit instruction set development. If you look at the Kuznechik left side of the slide and main XLPS function of Tribok right side, you can notice that first common part is XOR and SBox operation, which looks like obvious candidate for first custom instruction. Note that SBoxes are the same in Kuznechik and Tribok. Another candidate for Kuznechik is L-transform. Since it operates on 128-bit words, we split into two 64-bit instructions computing low and high part respectively. For P-transform of Tribok, which is 8 by 8 byte matrix transpose, we implemented via ZBP extension, which is former part of B extension. However, this BP extension was not included in version 1.0. Some another implementations are also possible, but we stopped on this one. Finally, L-transform for Tribok, which is a simple 64-bit by 64-bit constant matrix multiplication by 64-bit vector. It's quite low-cost operations and significantly improved performance. For Magma block cipher, we implement instruction which compute whole round. Some alternative implementations, lightweight implementations, are possible using instruction from K extension, which also shared with the B extension. For example, rotate reft operation and xperm4 operation. We implemented this set of instructions in toolchain, assembler, GCC, rolled encryption and decryption functions via intrinsic functions, and instructions were implemented in two our cores. One is BM610 microcontroller core, where we instantiate one execution unit for this set of instructions, and in our out-of-order core BI671, we implemented two execution units covering this instruction set. Note that all instructions were implemented in single cycle, and we did not observe effect on our critical parts of our course. Here, you can refer to some performance and area numbers based on these implementations. For your reference, we added some comparison with known implementation on Intel CPUs. As you can note, they are quite competitive in terms of speed, but of course, RISC-V solutions have much better per millimeter performance. We would like to contribute these instructions to the RISC-V standards. Perhaps ZKG would be a good name for it. Initial proposal of 64-bit version of instructions already have been done in mail list of crypto extension task group. And we are open to discuss improvements of these existing instructions, and we are still missing of ROE 32-bit instruction set, so we invite community to work on this together. So thank you for your attention in this lightning talk. Hello, everyone. Yeah, waiting for your questions. Okay, seems no questions at the moment. So yeah, let's wait for a minute. Okay, we got question where this code located on GitHub. So the initial versions of functions was placed on GitHub of our employees. So but if you look at so I think for the vote right now, I think we will you can find it that in mail list of crypto extension task group. So we already placed link of the draft implementation there, but it was linked to GitHub of one of our employees. So another question, are there known good solutions which publish results somewhere? So there is some papers implementing the Russian crypto algorithm on Intel CPUs, but until now we didn't see any reference comparing on RISC-V. Okay, so seems we have the time is ended. So thank you for your attention, and feel free to contact us via our site or info CloudBEAR group. Thank you.